So let's see what it says here. 51. Blah, blah, blah. Oh, all right. So the one that says 1 plus x times 2 minus x, that one?
Yeah.
Okay. So 51 looks like this here. If I had to guess, I would guess that possibly the problem you're having with this problem, how does simplification and factoring, how do they relate to each other? Simplify versus factor. They are exact opposites. Because simplify means do the operations. Factoring means undo multiplication, right? So sometimes people look at this and they'll see the simplify, and you'll start to try to factor it. No. So I don't know if that's what happened. So what do you actually have to do here then?
Foil.
Yeah, you got to foil. And what's the part of this problem that you got to be careful about? The negative, right? So negatives always find a way to screw us over. So that minus is going to be careful when you bring it through here. So you just got to foil these things out, right? So where did the trouble start to happen? Or maybe it was the negative that screwed it up?
Yeah, I looked at the backwards list. The backwards list was like x plus 7. Weird answer.
Oh, yeah. All right, what do you get when you foil this out?
Negative x squared plus x plus 2.
All right, so negative x squared. You got plus 2 minus 1x, so you get plus x plus 2.
Yeah.
And then here, what you can do for yourself is that. Right, just minus whatever that product is. You got to figure out what the product is first. This is kind of nice. What does that look like?
Conjugates.
Conjugates. I love it. I love the use of the word conjugate. And they're like a difference of squares pair. Right? So this would be easy. So 9, the middle terms cancel, blah, blah, and then you get minus x squared. So then when you bring that through, you get negative x squared plus x plus 2 minus 9 plus x squared. Yeah. So that's how that happens. So it's that minus that screws us up because we don't do what we're supposed to do with this thing. You could actually take the negative inside if you wanted to. You can make this negative 3 plus x and make this a plus sign. You can distribute the negative through first if you really wanted to. That'll work. Yeah, I agree. I wouldn't do that one. Okay, cool. Well, that should be a problem that you could sink your teeth into. It should be nothing too bad about that. Just be careful with the negative. Anything else from homework? Yes?
27.
Oh, yeah, 27 looks freaky. Let's see. Yep. I don't think I put, yes I did. We had one a lot like that on that warm-up sheet. The only trick with this one is they threw in there also fractional power. Well, what's the idea with the powers? What's a good first step here?
Move everything.
Move what?
The negative.
Everything's to a negative power, right? So the big mistake I see is people take 2r squared and put it up top. So if I put 2r squared up here, what mistake did I make?
You brought a 2 up.
Yeah, what's the 2? What's the power is the 2 being raised to? 1. The first power, so why the hell would it go anywhere? So only these 2 r's want to move, and these 3 s's want to move. Is this the only way to do this problem? No. You could just right off the bat start subtracting powers, right? When you divide, you subtract powers. But then you can have these negative mistakes come into play. So how do you avoid negative mistakes? Get rid of the negatives, right? So that's why, to me, this is what I always do first. Just move everything with a negative power. What's 8 divided by 2? 4. Neato. And then you got r to the 1/2 times r squared. These 4 s's are still there. And these 3 s's come down with. Is that cool?
Yeah.
Does everybody see that? Okay, and now you just do what with the powers? Combine them, add them together, right? So on the top you get 4r to the... Yeah, it's better than writing 2.5. Right? We kind of rather would write this as 5 halves. Because now I can see the power, I can see the root. Over s to the
7.
coolest. So there's a gimme. Yeah.
How do we get the me? How do you get the 5 halves on the top? I know it's 1 squared times 2, or 1/2 times 2. If you add them?
Yes, of course you do.
Oh, I see it now.
Good.
So it's
Good.
2 times.
If it would have been r to the 1/2 squared, then what would you do with those?
You would multiply.
And I did just say squared. Number one.
So it would just be r if that was the case.
Yeah.
Oh,
Cool.
okay, I see it.
But if you got 2 r's here and half of an r more, you have 5 halves of an r. Right? You just add those together. I like it. Oh, just a second. She was.
No, I just have another problem that I need help with.
Any other things on this here? All right, cool. What's up?
81.
Problem.
Oh, cool. All right. We're actually going to do that today. We're going to focus on those problems specifically today. Yeah. Yeah.
21.
Swap. Oh, yeah, more powers. All right, let's see. 21 looks like this here. The thing that saves your ass so many times is order operations. Because the mistake people make here is they multiply these together or something, but I mean, what order operation says to do what first? Bless you. Yeah, and can you really do anything inside here that's of any real value? I mean, you could put that on the bottom, but, you know, it doesn't really matter. Right? There's nothing really inside the parentheses you can do. So what's next?
Exponents.
Exponents. Cool. So how do you apply these exponents? Yeah, good. So I could never say that a plus b squared is a squared plus b squared, right? Please, dear God, don't do that. It's when my Calc 2 students do that I really start to cry, and they do. But of course that's not going to work, because exponents don't play with addition well. Alright? But exponents play really well with multiplication, because that's what they're based on. So it can totally just distribute to each. So what do I get here?
27.
Careful, 27. X cubed.
Why does it say
There's some dissension. 6, right?
it's on the outside?
This is actually the definition of multiplication. If I have 3 groups of 2 y's, that is how we first learned multiplication, right? 3 crates with 2 apples in each crate. How many apples you got? 5, because I was hungry. No, 6. Right? So don't tell me 8 one of them y's. And then the same thing over there. So what's 2/3 squared? 4/9. X to the -2y squared. Alright, I did enough of that problem for you. Now, the last step is to do what?
Multiply.
Multiply, right? 27 times 4/9, x cubed times x -2, so forth, right? Alright, good. So that's not done. You got one more step there. I'll let you guys do that last step. Anything else from homework?
60.
Ooh, yeah. I like it.
I couldn't remember what to do.
So 60. This is all, of course, that first homework assignment. Plus minus. Where'd you go? There you are.
Oh, we just have to find an LCD.
Exactly.
Oh, that's where I stopped.
Are you allowed to multiply by the LCD? Kill the fractions? kill the fractions. Yeah. Why are you not allowed to do that here? Yeah, it's not an equation. So I don't have two sides to balance me out. The minute students learn you can kill fractions, you're like, kill them all. Right? And you can't. You can only do it when you're legally allowed to. When you have two sides to something, you can balance it out by multiplying. But here, I can't multiply by LCD. I can't. I just have to get them all to have the same LCD, the same denominator, right? How do I figure out what the LCD is going to be? Good. You got to first see what the hell these guys have in them, right? So, of course, this would be what?
X plus 2.
And this would be?
X minus 1.
X minus 2, X plus 2.
Yeah, it's 2 and 1s, but the big one's got to be negative, right?
Yeah.
So the really good way to look at this is, who's missing something? What is this guy missing? He's missing an x minus 2 at least, right? I'm going to run out of room here. And an x plus 1. Ah. You guys kind of with me? That's a beautiful way to look at this. It becomes so easy. If you're able to factor, this kind of problem is so damn easy. Factor, see the parts, give everybody what they don't have. It's like having kids. You got more ice cream. Okay, have it a little bit. You got more ice cream. Okay, yeah. Okay, screw it. I'm eating the damn ice cream. Why? It's probably a good idea. I don't have kids. Because I would actually probably do that. And of course, this guy's missing
An X plus 1.
x plus 1. So he's happy now.
And X plus 2.
Right? And this guy's missing an x plus 2. And the only thing really, so now you're able to put all the top stuff over x plus 1, x plus 2, x minus 2. They all have the same denominator, right? And now you just have to, FOIL, get this, distribute negative 2 through there, right? And then get your like terms together. And you guys see where to go from there? That's the hard part of what we just did, really. It's just to remember how that works. Now should be the relatively easy part. Alright, so anything else from the homework? Yes?
63.
Is everybody cool with this one? Okay, alright. $63. A few more questions and we'll have the homework done. Let's see. Oh yeah, this was a good one. Recall. How do you rationalize, what do you got, Jeff? 2 over the square root of a. Yeah, multiply by the square root of a, right? Now, something I want to be real careful about. Let me show you one more example. And why do you do that? Let me kind of build up into what I'm going to say here to be careful about. Why do you do that? True, that's why I'm allowed to multiply by root a over root a, but why am I multiplying by root a over root a? Yes.
To get rid of the roots.
Yeah, get rid of the root. It's a square root, so how many things does it need inside? 2. Currently has 1a, so I give it one more a. Right? But students come away from this example with the exact wrong idea. They think, whatever's on the bottom, I'm going to multiply by it. No. You had 1a, you needed one more a. So if instead it would have been 2 over the 5th root of a. Do I multiply by 5th root of a over 5th root of a?
No.
Hell no. That doesn't make any damn sense. So I call this process completing the root. Complete the root. How many things does the root need? 5. How many do you have? 1. So how many more do you need? 4. Hey, all right. See, that's the correct concept behind this. But students, when you see this, that's why I want to teach this. I start with higher roots in the first place. So then they don't think, oh, just multiply by whatever it is. Yeah. Right? So here I have to multiply by 5th root of a 4. 5th root of a 4. So on the top I get 2, 5th root of a 4. What do I get on the bottom? A. I'll get the 5th root of a to the 5th, which is a. We built it to come out that way. Cool. I like it. And of course, could I cancel these in or reduce these?
No.
Hell no. Why not?
Not the same.
They don't have the same root. Cool. Right. You can't break into that root. You have to have the same root so you can reduce them. So I think finally, somebody, whoever asked the question, like, it has nothing to do with what I know. So the actual problem is, it has a little bit to do with this. So now here, this is the next level up from that. And this actually has something to do with a word somebody used earlier that I was excited that you used that word. Yeah. Conjugate. So the problem here is if I multiply by rad 3 because he needs one more 3, I'll still have a rad 6 there, won't I? If I multiply rad 2, I get the same damn problem. Right? So I actually have to multiply by the difference of squares pair, the conjugate. And that would guarantee that the middle term where the radical would still possibly be alive cancels. So I multiply by what exactly? Rad 3 minus rad 2. Become a rad. You can see what that does for me. Now I get rad 3 times rad 3. I gave that guy one more 3. So he becomes a whole 3. Aw. Square root's a half power. So that's why rad 3 times rad 3 is 3. It's because half of a 3 times half of another 3. They make a whole 3. Aw. And then rad 2 times rad 2 is 2. And then the middle term, rad 6, it kills itself, right? Plus and minus. That's the beauty of the conjugate. Same idea if it was complex down here. 5 plus I would multiply by 5 minus I. Why does it make sense it's the same? Because I is just square root of negative. It's the same thing. It's the square root. Alright. So then you just distribute. On the bottom you get 1 to gas. So on the top you'll get, well, let's go ahead and we're just about done. What do you get on top? Square root of 18?
Minus square root of 12.
Square root of 12 over 1. If you stop there, you're not right. Is equal over 1, of course. The bottom became 1. I like some of your faces right now. Is everybody kind of with me so far right now? Yeah, like... And why is that wrong if I stop there? It's sort of like telling me the answer is 4/8. I'm like, well, yeah, but we know you got to go further, right? So that's why I call this reducing the radical. It's not really reducing, but it feels like reducing a fraction. Is that one last step I got to do? So how can I reduce this? Yeah, it's 9 times 2. So square root of 9 is 3. Square root of 2, I don't know. And of course, that's 4 times 3. Square root of 4 is 2. Square root of 3, I don't know. Bam. And those I cannot put together because they are not like terms. Cool. 3 rad 2s minus 2 rad 3s. I don't know what the hell it is. It's like 3x minus 2y. I can't do shit with that. And let me make a point real quick about something. I didn't say this earlier. We are going through chapter 1 kind of quick. I'm not looking at chapter 1 as I'm teaching you anything in chapter 1. I'm going over it with you from stuff from chapter 1. So now's the time to bring up you forgot it or you never really understood it or whatever. Right? The rest of the class, all the other chapters, I'm not going to do like chapter 1. If you're worried, it's just the way the whole damn class is going to do shit. Well, no, this is review. This is not teaching. This is reviewing. All right. Is there anything else from homework? Good. All right. So what I want to focus on, I can answer somebody's question about number 81, is I want to let you guys work on these problems. Of course, whoever asked the problem about 81, you're just going to have to wait. I want to see how you guys approach these problems, and then I can figure out what kind of gaps I need to fill in about how to work word problems. But you should have been working on word problems ever since Math 90. So there's got to be some kind of way that you approach them. Your way might be to skip them over. We need to stop that now. Right? That's how I approach them. Around. No good. So let me ask you this. Who needs